Good morning, students. Myself, Vijay Shankar from Electronics and Communication Engineering Department at Chevrolet Engineering College. Today, we are going to discuss about another some of the examples of the Fourier transform. So, we already discussed about the Fourier transformation and properties of Fourier transformation and some of the examples. Standard signals, unit sample, unit step signal, impulse signal, and the signum function, Fourier transformation. And some more another examples of the Fourier transformation. We already seen the exponentially decaying function e power minus at. And now you see the e power plus at, exponentially rising function. Exponentially rising function. See here, in the last class we seen the e power minus a, the magnitude of t, e power minus a, the magnitude of t, having the two functions, my dear students. So one is e power minus at, another one is e power plus at. So what is the Fourier transformation of the exponentially rising function? Exponentially rising function. So let x of t is equal to e power plus at into mu of t. Plus at mu of t. Okay. So by the definition of Fourier transformation, x of omega is equal to integral minus infinite to infinite x of t e power minus j omega t dt. Minus j omega t dt. So that integral minus infinite to infinite. Now what is the e power plus at mu of t is a given signal. E power plus at mu of t means a step function, my dear students. It's a step function. And e power minus j omega t dt. Now keep the mu of t as a 1, change the limitations from 0 to infinite, and here the basis for the same, write as the powers you have to add, taking off t as a common, a minus j omega. A minus j omega into dt. Okay. Now, the integral of e power function, the t into a minus j omega whole divided by a minus j omega. With upper limit is infinite, lower limit is 0. When you can substitute upper limit is infinite, e power infinite is a 0, lower limit e power 0 is a 1 minus 1 whole divided by a minus j omega. A minus j omega. So x of omega is equal to the e power minus at, not the minus, it is a plus, my students, e power plus at mu of t, e power plus at mu of t. Function is a minus 1 by a minus j omega, a minus j omega. So otherwise, we can take it is x of t is equal to e power at mu of minus t. So mu of minus t means is a folded function, my dear students. Folded function. So x of omega is equal to integral minus infinite to infinite x of t e power minus j omega t dt is equal to integral minus infinite to infinite. What is x of t here? E power at mu of minus t as x of t signal, e power minus j omega t dt. Okay. Now, you see the mu of minus t means a folded function. So mu of t look like as a 1 is a magnitude for mu of t. From 0 to infinite, the t is varies, the magnitude is a 1, and remaining here the 0. But mu of minus t is a folded function. Mu of minus t having the value is 1 from minus infinite to 0. The reverse. You can keep the mu of minus t is equal to 1 by changing the limitations as minus infinite to 0. Here we change the 0 to infinite. And here it is a minus 0 to minus infinite to 0. Since here it is a mu of t and here it is a mu of minus t. So e power at minus e power, not the minus, my dear students, both the bases are the same. You can take t as a common, a minus j omega into dt. Okay, so mu of t is mu of minus t is equal to 1, and now the limitations is changes from minus infinite to infinite as minus infinite to 0 is equal to okay. Now e power t into a minus j omega whole divided by a minus j omega with upper limit is 0, lower limit is a minus infinite. Upper limit is a 0, lower limit is a minus infinite. By substituting the upper limit, e power 0 is a 1 minus lower limit e power infinite is a 0 whole divided by a minus j omega is equal to 1 by a minus j omega. 1 by a minus j omega as x of omega. The Fourier transformation of e power at mu of minus t and e power at mu of t. There is a lot of difference here. It is a negative sign and here it is a positive sign. Denominator is a minus j omega. So we can call it as a single-sided, only the positive relaxes. And this is also single-sided, but it is a negative mu of minus t. It is also single-sided and this is also single-sided, but it is a positive values of t and this is the negative values of the t function. E power at and e power at both are rising functions only. exponentially rising function in negative values of t and the positive values of the t, 1 by a minus j omega, and this one is a minus 1 by a minus j omega. Okay, my dear students, we already seen e power plus at, e power minus at mu of t, e power minus at mu of t. You see here, e power minus at, a into the single-sided exponential, the Fourier transformation of a single-sided exponential signal. This is arbitrary signals and the standard signals. Standard signals means a step function, impulse function, exponential function, and sinusoidal or the cosine function, sine and the cos. First, we can take the Fourier transformation of a single-sided exponential signal. Single-sided exponential signal. That x of t is equal to a into e power minus at. A is a magnitude, my dear students. Here this exponentially decaying function because e power minus at, exponentially decaying. It starts from the magnitude of a. Otherwise, you can keep it as a is equal to 1. Or x of j omega, or the digital omega, x of omega, or x of j omega. All it is the same. So x of j omega is equal to integral minus infinite to infinite x of t e power minus j omega into t dt. Substitute the x of t is a into e power minus at and e power minus j omega t dt. So a is a constant, and when I am keeping that mu of t, so it is a t is greater than or equal to 0, or it is a mu of t is equal to 1 over. Okay, from 0 to infinite, only if I am taking the 0 to infinite, since the given it is a t is greater than or equal to 0. 0 to infinite, a into e power minus of a plus j omega into t dt. Apply the integral for the exponential signal. With upper limit is infinite and lower limit is 0. Upper limit becomes of the 0 here, and for the lower limit is 1. Minus into minus here the plus, a by a plus j omega. Let a is equal to 1. What it is, x of omega is equal to 1 by a plus j omega. Okay, is a Fourier transformation of the single-sided exponentially decaying function. X of omega is equal to. Okay, double-sided means yesterday only we seen a double-sided exponential signal is a into e power minus of a with the magnitude of t for all the values of t here. X of t is equal to, if I am taking that is that t is a negative values, so minus infinite to 0. If t is negative values, from t is equal to minus infinite to 0, minus infinite to 0, the magnitude of t here it is the minus, minus into minus is a plus, and a into e power minus at, the t value is a positive, it is a minus at. So two-sided. So one is a positive values of t, and another one is the negative values of the t. You can call it as a double-sided exponential signal. Double-sided exponential signal. Okay, my dear students. Now, to split the integration with the two parts, minus infinite to 0 and the 0 to infinite. One is e power at. E power at is 1 by a minus j omega. 1 by a minus j omega, and here it is a 1 by a plus j omega. Okay. Now, e power 0 by a minus j omega means 1 by j omega. 1 by a minus j omega. E power infinite is a 0. E power infinite is a 0. This value is a 0 here. This term. And e power infinite, this third term is also the 0. And minus into minus here, the plus 1 by e power 0 is a 1. 1 by a plus j omega. So let us take the a is a 1. 1 by a minus j omega. 1 by a plus j omega. Take it as LCM, a plus j omega plus a minus j omega. So minus j omega plus j omega get cancelled in the numerator. We have the a plus a, 2a, and denominator a square minus b square. J square is equal to 1, so it is a square omega square. It's a double-sided exponential function. It's a 2a by a square plus omega square. 2a by a square plus omega square. Remember, my dear students. If suppose you can get the doubt, what is the e power at mu of minus t? Mu of minus t. Let you can see that also. We already seen the x of t is equal to e power at mu of t. X of t is equal to e power at mu of minus t. Now, we already know if x of t is equal to e power minus at mu of t, the x of omega is equal to, we got 1 by a plus j omega. A plus j omega. Okay, my dear students. Now, what it is, the x of t is equal to e power minus at mu of minus t. Now, let us take the x of omega is equal to integral minus infinite to infinite x of t e power minus j omega t dt. Okay, is equal to, what is x of t? Integral minus infinite to infinite e power minus at mu of minus t e power minus j omega t dt. Okay, my dear students. What is a mu of minus t is a 1 with the range of minus infinite to 0. So e power minus you can take as a common a plus j omega. A plus j omega into dt. That is equal to, now you can take it as e power minus t a plus j omega whole divided by a plus j omega with upper limit is 0 and lower limit is a minus infinite. So substituting the upper limit, here the minus is also there, my dear students. Minus of minus of it is. Okay. So upper limit is a 0 means 1 minus lower limit is infinite is a 0 whole divided by minus of a plus j omega. A plus j omega. that is equal to minus 1 by a plus j omega. X of omega is equal to, okay, x of omega is equal to a plus minus of a plus j omega. It is a plus. E power a minus at mu of t is a plus we got, and e power minus at mu of minus t. It is a t values is negative values and the t values is a positive values. So see here, the t values is a positive. We got here the minus 1 by a minus j omega, and for the negative values it is a positive 1 by a minus j omega. This is equal to minus 1 by a minus j omega. Remember, my dear students, this is a plus 1 by a minus j omega and it is a minus a minus j omega. And denominator here the 1 by a plus j omega and minus 1 by a plus j omega. Alright. The single sided, and it is a double sided, the 2a by. What is a double sided? X of t is equal to e power minus a, the magnitude of t. What is x of omega is equal to? X of omega is equal to 2a by a square plus omega square. Okay. Have to remember this is standard or the arbitrary signals of the Fourier transformation of arbitrary signals or the standard signals. Now coming to all the exponentials we receive, e power minus at mu of t, e power minus at mu of minus t, and e power plus at mu of t, and e power plus at mu of minus t. So positive values and the negative values of the t for both the exponentially decaying function and exponentially rising function Fourier transformation we find, or we obtain the Fourier transformation of the signals. Coming, if the signal is multiplied with the t, the signal is multiplied with the t ramp signal, what is a Fourier transformation? What is a Fourier transformation? Let us see. So we seen the Fourier transformation of e power minus a minus of a into t is a by, or it is not the a by, e power minus at is a 2a by a square plus omega square. Okay, 2a by a square plus omega square. It is a capital A is a magnitude, my dear students. It is a value is 1. Okay. And Fourier transformation of a constant, yesterday we did x of t is equal to 1. X of t is equal to 1. If the definition of Fourier transformation is directly applied, the constant will not satisfy the condition integral minus infinite x of t dt is less than infinite, because it is a value is infinite. Why? Let us see here how it is not satisfy this condition, absolutely not integrable. Let the x of t is a constant. What is a Fourier transformation definition saying? X of omega is equal to integral minus infinite to infinite x of t e power minus j omega t dt, e power minus j omega t dt, my dear students. See, what is x of t is a is a constant or 1. Let x of t is equal to 1. I'm directly taking that is integral minus infinite to infinite 1 into e power minus j omega t dt. So 1 is the input signal. You have to find out the Fourier transformation of a constant 1 or Whatever it is a here, you can keep the a's also. Integral minus infinite to infinite e power minus j omega t dt. What is e power minus j omega t? E power minus j omega t whole divided by minus j omega with the limitations is a minus infinite and the plus infinite. Here it is a minus, sorry, it is a plus. After substituting the values e power infinite and the e power infinite, 0 minus 0, it is a 0 value. So it is not satisfies the condition here. So we are going to find out the constant Fourier transformation of the constant with the duality property. With the duality property, my dear students. What is the duality property saying? X of t is equal to, or x of t is a Fourier transformation pair of x of t means it is not the small letter x of t is a Fourier transformation pair of 2 pi the delta of omega. X of t is a 1. So 1 is a Fourier transformation. Actually it is a x of omega. It becomes of here the 2 pi delta of omega. The 1, the Fourier transformation is a 2 pi delta of omega. Okay. For that, to prove the magnitude here, see, the Fourier transformation of A is 2 pi into delta of omega. A is a constant. A is a constant. Or without that, using the duality property, we can also find out like this. See the double-sided exponential signal, we know the x1 of t is equal to a into e power minus a, the magnitude of t. E power minus a into magnitude of the t. And the Fourier transformation of x of t, you can see here the Fourier transformation of x of t, that this signal is a x of t and a into the limit a tends to infinite x1 of t. A tends to 0, x1 of t. What is x1 of t here? A into e power minus a, the magnitude of t. Following my difference. And taking the Fourier transformation on both sides, x of t is a Fourier transformation of x of t and the Fourier transformation of limit a tends to 0, x1 of t. What is x1 of t? E power minus a, the magnitude of t. The Fourier transformation of x of t is a x of j omega or x of omega. Limit a tends to 0, the Fourier transformation of x1 of t. What is the x1 of t? We already know 2a by a square plus omega square. 2a by a square plus omega square. Already we have the a is a magnitude. A is a magnitude. 2a capital A omega square plus a square. That is a limit a tends to 0 is equal to 0 because limit a tends to 0, you can substitute the 0 here for all the values of omega except at omega is equal to 0. At omega is equal to 0, the above equation represents an impulse of the magnitude k. At omega is equal to 0. Let us see the omega is equal to 0 means the value is a 0 here. 2a capital A by a square and a get cancelled, the 2a by the a1. So x of j omega, that is k into impulse function, the delta of omega. At omega is equal to 0 and 0 for omega not equal to 0. Whenever it is omega is equal to 0. The magnitude of k can be calculated as for this integral minus infinite to infinite 2a capital A by omega square plus a square into d omega, and 2a with a is a constant, my dear students. So we have with respect to the omega, we are applying as an integral minus infinite 1 by omega square plus a square into d omega. We know the integral 1 by a square plus x square dx is a 1 by a tan inverse x by a. Using this trigonometric function, you take this as a 2a, capital A is a constant, to 1 by a tan inverse omega a with infinite and minus infinite. Plus infinite is a pi by 2, minus infinite is a minus pi by 2. Since the tan is a odd function, 2a, capital A, 1 by a into pi by 2, minus of minus is a plus, pi by a get cancelled, and we have only the 2 capital A into pi, 2 capital A into 5. Therefore, the Fourier transformation of A is 2 pi A into the delta function. 2 pi A into the delta function. This is a little bit complex. So, going like this by taking the double-sided and the taking of the Fourier transformation of assuming signal of x1 of t as x of t is equal to, and doing all this, there is a little bit confusion. So, we are going to an indirect method by using the property. That property is a duality property. So, duality property directly saying that x of t is equal to, x of t is a Fourier transformation pair of 2 pi into x of omega, x of minus omega, my dear students, x of minus omega. Duality property saying that. So, x of t is equal to 2 pi into x of minus omega. Okay, my dear students. It's not equal to, this is a Fourier transformation pair. That x of t is a 1, the Fourier transformation. If it is a constant, that x of omega becomes delta function, delta of minus omega. Since the symmetric delta function is a symmetric or the even function, minus omega is a delta omega. So 1 with the Fourier transformation, is 2 pi into delta omega. Remember this one. Okay. So the next one is a Fourier transformation of the step function. Fourier transformation of a step function. For the step function, directly we can find out by using the Fourier transformation definition, we get 2 by j omega. 2 by j omega. But with the signum function, signum of t, we know that 2 into mu of t minus 1. So mu of t is equal to 1 by 2. Mu of t is equal to signum of t plus 1 by 2. So x of t, let it is a x of t is equal to mu of t. Apply the Fourier transformation on both sides. Fourier transformation on both sides. The Fourier transformation of mu of t is equal to Fourier transformation of 1 by 2 and Fourier transformation of 1 by 2 the signum of t. And 1 by 2 into, what is the Fourier transformation of 1? 2 pi into delta of omega. A is a constant, my dear students. 2 pi into delta of omega. What is the signum function Fourier transformation? In the last class we have seen the signum function also. Signum function Fourier transformation is 2 by j omega. So here the 1 by 2 and the 2 is get cancelled and the 2 and 2 get cancelled. The Fourier transformation of mu of t is pi into delta omega plus j omega, 1 by j omega. 1 by j omega. See here the Fourier transformation of signum function is 2 by j omega. 2 by j omega. The next one is Fourier transformation of the sinusoidal signal and cosine signal. Say arbitrary signals or the standard signals. We already find the impulse function, we already find the unit step function, and we already find the signum function, and the remaining is the sinusoidal function and the cosine function. Before going to discuss about the sinusoidal function and the cosine function, you have to see what is the Fourier transformation when the ramp function is multiplied with the exponential. Okay, let us see here there is anything. Let's see. Obtain the Fourier transformation of x of t, the t into e power minus at mu of t. T into e power minus at mu of t. What is the e power minus at mu of t here? We already seen e power minus at mu of t is a 1 by a plus j omega. 1 by a plus j omega, my dear students. See. So, e power minus at mu of t. What is the Fourier transformation is? Fourier transformation is 1 by a plus j omega, my dear students. J omega. And now for this, t into e power minus at mu of as an x of signal x of t. So I want the definition of the Fourier transformation. X of omega is equal to minus infinite to infinite x of t e power minus j omega t dt. As x of t can substitute as a t into e power minus at mu of t into e power minus j omega t dt. What is the mu of t is a 1 for t is greater than or equal to 0. So change the limitations here from 0 to infinite, t into e power minus at e power minus j omega t, and substitute the value is a 1. And substitute the value is a 1, my dear students. And then, see, directly you can apply the integral for t, and or otherwise if it is a exponential. If combining the signals, the t into e power minus a plus j omega into t dt means you can apply the UV rule or integration by parts. Integration by parts. That is, first of all, if I am taking the u integral v, see my dear students here, what is the formula for the UV rule? Integral uv, it is a uv dt is equal to, first you can take u, apply the integral for v dt minus the derivative of u d by dt of u, integration by parts, my dear students. Integral for this integral and derivative and integral of v into dt. Okay, this is a formula for the UV rule. So first, what is the u here? T, and what is the v? E power minus of a plus j omega into t dt. I take the u as a t, and integral of v e power minus a plus j omega into t dt minus of, here the integral, the derivative of u with respect to the t. See, the t value is there, derivative of t is 1, and then integral of v into dt. What is the integral of v? E power minus of a plus j omega into t by minus a plus j omega, because it is a coefficient of t is minus a plus j omega into dt. The limitations is infinite and the 0. Again, here there is a 2 integrals, my dear students. You see the 2 integrals. Apply here t into, for this integral, e power minus a plus j omega into t, and t coefficient is minus a plus j omega, plus already we have the minus into minus is a plus 1 by a plus j omega. Again you can apply the integral of e power minus a plus j omega into t dt. That is e power minus of a plus j omega into t whole divided by minus of a plus j omega into, with upper limit infinite and lower limit is a 0. Now you can substitute the infinite first of all. Infinite with two terms, e power infinite and e power infinite. First two terms is a 0. Okay. For the second limit, apply here the t is there. So with the t nothing but the 0, the third term is also 0, my dear students. Only we have the fourth term. What is that fourth term? Because it is a lower limit, how to get it is a minus of this function and minus of this function. You can substitute the value is a t is equal to 0. So minus into here the minus is at the plus. E power 0 is a 1. 1 by a plus j omega and a plus j omega. 1 by a plus j omega whole square. 1 by a plus j omega whole square. Remember, my dear students, it is t into e power minus at mu of t. The Fourier transformation is 1 by a plus j omega whole square. See here, what is the e power minus at mu of t? The Fourier transformation is 1 by a plus j omega. Whenever there is any ramp function is multiplied for the e power minus at, it becomes of square. It becomes of square. 1 by a plus j omega. It's a very important matter, students. When the t is multiplied with this function exponentially decaying with a single sided exponential function, it multiplies with 1 by a plus j omega is already there. It is a 1 by a plus j omega. So 1 by a plus j omega whole square. With this concept, now tell me, so what is the Fourier transformation of t into, suppose if I am multiplying here, the t into e power minus at mu of t becomes 1 minus 1 by a minus j omega whole square. Understood, my dear students? When x of t is equal to t into e power at mu of t. T into e power at mu of t means it is a 1 by a minus j omega whole square. Following? Here also, if suppose if I multiply the t, what is the Fourier transformation of e power at mu of minus t? Is a 1 by a minus j omega whole square. Means any function, the Fourier transformation is there. That Fourier transformation is a square when we multiply with the ramp function, the t. The t is equal to. Following, my dear students, the t. Okay. T into e power minus at mu of t, the Fourier transformation is 1 by a plus j omega whole square. So this is a signum function we already seen. X of omega is equal to as a 2 by j omega. 2 by j omega. Now you can see the sinusoidal signal and cosine signal. Sinusoidal signal and the cosine signal. Before it is a little bit confusion, you see the Fourier transformation of 1. I already told the magnitude of d or t, the integral minus infinite to infinite dt is tends to infinite. That is, a discrete condition is not satisfied, but its Fourier transformation can be calculated with the help of duality property. It's not absolutely integrable. It's not absolutely integrable because it is a constant value, as a constant value. So delta of t, the Fourier transformation, we already know the 1. Here, the x of omega is equal to 1. X of omega is equal to 1. So delta of t is a Fourier transformation of the 1 I replace with the x of omega. The duality property states that x of t is a Fourier transformation pair of 2 pi into x of minus omega. 2 pi into x of minus omega. Here x of t is equal to 1, then x of minus omega will be the delta function because there is a Fourier transformation relation is there. So 1 with the Fourier transformation is a 2 pi delta of minus omega. Since it is an impulse function, delta of omega will be the even function of omega. Even function of omega, delta minus omega is equal to delta omega. So 1 with the Fourier transformation is 2 pi delta omega. 2 pi delta omega. If x of t is equal to 1, x of omega is equal to 2 pi delta of omega. Remember, my dear students, these are very important. So using this Fourier transformation of the constant to nothing but it is a 1, to find out the Fourier transformation of the cosine and the sinusoidal signal. Okay. So the Fourier transformation of the sinusoidal signal, x of t is equal to a into sine omega naught t. A into sine omega naught t. I will show in the whiteboard, my dear students. See, Fourier transformation of a sinusoidal signal. What it is, x of t is equal to sine omega naught t. Sine omega naught t. What is the sine omega naught t? In exponential values, e power plus j omega naught t minus e power minus j omega naught t by 2j sine function. So the Fourier transformation of x of t, Fourier transformation of x of t is equal to the Fourier transformation of the sinusoidal signal sine omega naught t, that is the Fourier transformation of writing it as e power j omega naught t minus e power minus j omega naught t by 2j or you can rewrite this function as the Fourier transformation of x of t nothing but x of omega, my dear students. X of omega is equal to, rewrite this function as a Fourier transformation of first function e power 1 by 2j e power j omega naught t as a one Fourier transformation minus the Fourier transformation of e power minus j omega naught t by 2j by 2j. So again it is rewrite as 1 by j is take as a common here is a Fourier transformation of 1 by 2 e power j omega naught t minus, here also the 1 by j is a common Fourier transformation of Fourier transformation of 1 by 2 e power minus j omega naught t. Okay, my dear students. See, for this Fourier transformation, 1 by 2 the e power j omega naught t, we already know 1 with the Fourier transformation is, what is the 1 Fourier transformation? The constant Fourier transformation is 2 pi into delta omega. Now I am taking the cross multiplying. 1 by 2 the Fourier transformation is 1 by 2 the Fourier transformation is pi into delta omega. Okay. So 1 with the Fourier transformation of delta omega, and it is a exponential e power j omega naught t. E power j omega naught t means directly you can substitute in the Fourier transformation equation. The Fourier transformation equation, there we have the x of t is equal to integral minus infinite to infinite x of t e power minus j omega t dt. See, if I am substituting the 1 by 2 is e power minus j omega t, integral minus infinite to infinite 1 by 2 as x of t signal, my dear students. Here e power minus j omega t and the e power j omega naught t. Take the common as e power minus j, you can take as a common omega minus omega naught t dt. Okay. Since here it is not the x of t, my dear students, sorry. It is x of omega. Suppose x of omega is equal to e power j omega t. Now, after substituting the 1 by 2, e power minus j omega minus omega naught into t dt means it is a Fourier transformation of 1 by 2 only. Fourier transformation of 1 by 2. What is the Fourier transformation of 1 by 2? Pi into delta of omega. What is the omega here? It is not the omega. In terms of the omega, it is omega minus omega. So 1 by 2 the e power j omega naught t. The Fourier transformation is 1 by j into pi delta of omega minus omega naught. Omega minus omega naught minus 1 by j into it is also similar, but here it is a minus is there. Minus means now it is a plus. So e power minus j omega naught t, and here e power minus j omega naught t. Take the minus as a common, it becomes a plus pi into delta of omega plus omega naught. Is x of omega is equal to the Fourier transformation of the sinusoidal function pi into delta omega minus omega naught minus pi into delta omega plus omega naught whole divided by the j. Okay, my dear students. This is by using the Fourier transformation of 1 or the Fourier transformation of 1 by 2. So see here, the same thing. Delta pi into delta omega minus omega naught plus delta pi into omega plus omega naught. Now we got the Fourier transformation of 1 by 2 e power j omega naught t is the pi delta omega minus omega. You write the first of all the sinusoidal function in the exponential value. Take the Fourier transformation on both sides. The Fourier transformation of the e power j omega naught t and the Fourier transformation of minus e power j omega naught t with 1 by 2 e power j omega naught becomes of 2 pi delta omega minus omega naught minus 2 pi delta omega plus omega naught. Okay, my dear students. Similar with the cosine function also. What is the cosine? A by e power j omega t plus e power minus j omega t only. There is no any j in the denominator. But this is also the same thing. You have to apply the Fourier transformation by using the 1 with the Fourier transformation of 2 pi delta omega and 1 by 2 the Fourier transformation of pi into delta omega. What is the difference here? Only the a pi, the delta omega minus omega naught, instead of minus here the plus. And there is no any j in the denominator. The cosine function is e power jx. So cos x is equal to e power jx minus, not the minus, it is plus e power minus jx by 2. Using this relation, apply the Fourier transformation on both sides, and the constant Fourier transformation 2 pi by delta and 1 by 2 the cross multiply. 1 by 2 Fourier transformation is pi into delta omega. Okay. So with this, the completion of the Fourier transformation of the arbitrary signals, or it also called as a standard signals, my dear students. So this is a Fourier transformation of arbitrary signals and the standard signals. First one is exponential, e power minus at, and single-sided and the double-sided. Single-sided and the double-sided. Next one is a Fourier transformation of the constant, which is not satisfying the discrete conditions. It's not absolutely integrable. You go for the either by using duality property or by using this one. It is some complicated. So you better go for the by using duality property only. It is easy way to find out the Fourier transformation of the constant and Fourier transformation of the step, Fourier transformation of the sinusoidal signal, and Fourier transformation of the cosine signal. Okay, and we already seen the Fourier transformation of the x of t is equal to t into e power minus at mu of t. For the exponential, you can multiply the ramp function. You'll get the square of that one. Square of the Fourier transformation of exponential. T into e power minus at mu of t, the Fourier transformation is 1 by a plus j omega whole square. Otherwise, the t into e power minus at mu of minus t. You see here? If x of t is equal to t into e power at mu of minus t. Mu of minus t is a minus, my dear students. What is a Fourier transformation x of omega is equal to, since e power at mu of minus t is 1 by a minus j omega. Now it is multiplied with the t, it becomes of square here. Following, my dear students. And also see in the last class the signum function. The signum function for positive values of t, the magnitude is 1. For the negative values of t, the magnitude is a minus 1. So these are mu of t and the mu of minus t, or the mu of t minus mu of minus t. Okay. You can solve by using the mu of t. The first one, x of t, is a positive value. For the minus infinite to 0, minus infinite to 0 is a minus 1. And 0 to infinite, the value is a 1, e power minus at. Take the e power minus j omega t minus j omega with upper limit is 0. Lower limit is a minus infinite. And here also e power minus j omega t. Apply the integral. Upper limit is infinite and lower limit is 0. 1 by j omega. And here it is a minus already there. Since the magnitude is a minus here. Minus into minus is a plus. 1 by j omega e power infinite is a 0 and is a 1. Suppose here, okay, upper limit is a 0 and lower limit is a infinite. So 1 by j omega is the first term. And the second term, upper limit is a infinite means a 0. For lower limit is substituting the minus, will get the minus into minus is a plus j omega. So 1 by j omega. So 1 by j omega, 1 by j omega is the 2 by j omega. And already seen the Fourier transformation of the one constant using the duality property. Okay. And you can see the remaining some more examples in the next class. Any doubts, my dear students? Please rise. Okay. Thank you.